Hello everyone. The title of this video is Solving Equations in Quadratic Form. Now each example I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org, and I'm in their Algebra and Trigonometry text, section 2.6, Other Types of Equations, and I'm under the heading Solving Equations in Quadratic Form. Now each example I'm doing is either an example taken directly from the reading here, or from one of those try it problems in the reading, or from one of the exercises at the end of this section that's related to this particular objective. I would ask that when I start a new example that you pause the video and try to work it out yourself first before watching me doing it and comparing, because I really feel that you should be practicing these things on your own, instead of just watching me do them. Okay, so all my examples are written out on paper, and we're just asked to solve each equation. Right? Find all the values that you can replace the variable with to make a true statement. Alright, so each of the equations in this particular video are going to be an equation that's in quadratic form. Right, quadratic form. So that means it can look like the following. A times some expression, which I'll use u to represent some variable expression. A times u squared plus b times u to the first plus c equals 0. Right? This would be the standard quadratic form where a, b, and c are real numbers. Right? They're just constants. U equals some variable expression. Right? And of course a is not 0, because if a were 0, then it wouldn't be quadratic anymore. So if you can write an equation this way, then it's in quadratic form. And that means it can be solved in a very similar fashion to a quadratic equation. Remember how you could use the quadratic formula, solve by completing the square, or even factoring if factoring were possible. But what you're going to notice about these equations in quadratic form is that if you take everything to one side, 0 on the other, if one of the terms has an exponent that's double the exponent on another term, and then you have a constant, then you have quadratic form. Right, so look at this example here. Right, look at this example here, number 1. We have 3 times x to the 4th minus 2x to the 2nd, and then a constant term, minus 1, equals 0. Everything on one side, 0 on the other. And if you look at this, right, the exponent of the lead term, right, exponent of the lead term, that first term, is double the exponent of the second term, or the middle term. Right, and that's kind of a key to recognizing that some equation is in quadratic form. All right, and then again, after that first term and middle term, you have a constant, all right, plus c. All right, so here's what I'm going to do, and also what they suggest you do in the reading of the textbook, is we're going to make a substitution. All right, we're going to make a substitution to transform our equation into a quadratic equation. You'll see what I mean in a second. So transform the equation into an actual quadratic equation in some variable, right? It's not going to be the variable we started with, you'll see. Transform the equation into a quadratic equation. And here's what I mean by this. We're going to right, I'll just write substitute. Now you see here, you know what? Instead of substituting right now, let me show you how this looks exactly like my quadratic form over here. You know, the a is the lead coefficient, that's 3. And then x to the fourth, you know, if I write that as a square, right, some variable expression squared, x to the fourth is actually x squared squared. All right, if you remember that power to a power property. All right, and then the b is -2. Right, you got -2 times, and then u, you know, to the first power. Well, again, the u here, the variable expression being squared in that first term is x squared. This is like having x squared to the first in that middle term, right? X to the second power. And then you have plus c, which is the -1. All right, so now I can see what to substitute for more easily. If I replace x squared with some letter, some other letter, something other than x, then we'll be transforming this equation into a quadratic equation in that new variable. So here comes the subbing part. Right? I'm going to let x squared, right? I see x squared squared here, x squared to the first here. I'm going to replace x squared with, you know, some other letter. I'll just use u, like back in my quadratic form. So now this becomes, you know, 3 times, and then, you know, x squared squared, and x squared is u. So 3u squared minus 2 times, and then x squared to the first, or just, you know, u to the first, or just u. And then minus 1 equals 0. And now what we have, like I was saying over here, you know, after making this substitution, first off you have to recognize that it's in this quadratic form. But after making this substitution, we have transformed this into a quadratic equation, right? This is quadratic in the variable u. All right, they would say this is quadratic in u. All right, so I make a substitution. Then, you know, after that step, solve for the new variable. All right, solve for this substituted variable. So I'm going to solve this for u. Now again, it's a quadratic equation. You could use the quadratic formula, solve it by completing the square method. But this one is nice and factorable. Alright, so I'm going to factor this. You have 3u in one factor. You know, you can factor it by the grouping method, or, you know, guessing and checking, whatever you like. I would need a -1 in this factor and a +1 here, right? And then double check that. That's 3u squared minus 3u plus 1u would be -2u, and then -1. Great. And then applying the zero product property, right? A product is only equal to 0 when, you know, at least one of the factors is 0. 3u plus 1 is 0 when u is -1/3, right? Or, you know, and u minus 1, the other factor, right, is 0 when u equals +1. Alright, so I solve for the new variable. Now these are solutions to this equation, right? The equation with u in it. But I don't want to solve the equation with u in it. I want to solve the equation with x in it, right? The original equation had this variable x. So then the next step, right, after solving for the substituted variable, we substitute back, right? Sub back and solve for the original variable. Okay, so here comes the sub back part. Right, sub back. So remember, every time I see a u, right, u was replacing x squared. So now I go back and change all the u's to x squared. So this equation becomes x squared equals negative 1/3, or in here x squared equals 1. And we solve these for x, solve for the original variable. Now in both of these I can apply the square root property. Right. So in this first one we get x equals either the principal square root of negative 1/3, or x equals the opposite of the principal square root of negative 1/3. And these are going to give me an imaginary solution. Remember, the square root of a negative number is not real, it's imaginary. And then this one here, right, we'd get x equals 1 or negative 1, right? The square root of 1 is 1, and the opposite of that is negative 1. And these are imaginary, right? I'm going to rewrite these with that number I. And remember, the square root of 1/3, just doing this off to the side here, that's the square root of 1 divided by the square root of 3, and then I would multiply the numerator and denominator by the square root of 3 to rationalize the denominator, right? That's the square root of 3 divided by 3 when you rationalize the denominator. So here we have the square root of 3 divided by 3, times I. Remember, hopefully you remember how to rewrite the square root of a negative as just the square root of the positive, times this I. And remember that I is the principal square root of negative 1, right? Don't forget that junk. Right? Or x equals, negative that, right? Negative square root of 3 divided by 3, and then times I. All right, and then finally, of course, the last step in any equation solving is to check your solutions. And you always check, or back in the original equation. Right. Now I have here 4 things to check. Now you can do them by hand. Right, well, I'll do this one by hand first, and then I'll show you how I would also do it on a calculator. So let me check. Alright, so the easy ones to check are the real numbers, right? How about x equals 1? Back here, you would have 3 times 1 to the 4th minus 2 times 1 squared minus 1 equals 0. This would end up being 3 minus 2 minus 1 equals 0, and this is definitely 0 on the left, 0 on the right. That works. Right. So I'll circle that one. All right, x equals 1 works. Hooray. Let me test x equals negative 1. Now it would end up being the same. Alright, so I'm going to kind of cheat on you a little bit. Replace, x with negative 1, and negative 1 to the 4th would be positive 1. Negative 1 squared would be positive 1. You get the exact same stuff. So x equals negative 1 also works. Okay. Alright, then how about x equals this, now this is, I'll just write it as the square root of 1/3 times I, right? Or you could again write the square root of 3 divided by 3 times I, same thing. Let's test this out. So we have 3 times, the square root of 1/3 times I to the 4th minus 2 times the square root of 1/3 times I squared, and then minus 1, and let's see if that's equal to 0. Well, here you'd have 3 times, now the square root of 1/3 squared is 1/3, but this is to the 4th, so this would be 1/3 to the second power, 1/9. Right? That's 3 times 1/9 times, and then I to the 4th. Now I'm hoping that you remember your powers of I from an earlier section in this book, or from an earlier video of mine. Remember, I to the 4th is just 1. So this ends up being 3/9, which is 1/3. Right? So this first term ends up being 1/3. Then we have minus 2 times, and then the square root of 1/3 squared would be 1/3 times I squared. Remember, I squared is -1, right? I is the principal square root of -1, so I squared is -1, so this is plus 2/3. And then we have minus 1, which is 3/3. And is this equal to 0? Absolutely. 1/3 plus 2/3 is 3/3. That'd be 1 minus 1 is 0. We get 0 equals 0. Hooray. So this works, right? The square root of -1/3, right? This square root of 1/3 times I, or square root of 3/3 times I, works like a charm. And the only difference would be, when I check the other one, it would be this would be minus, this would be minus, and it would end up being all the same stuff. Right, I promise you. So this works as well. So you have 4 solutions, and that should be the case. When you have a degree 4 polynomial equation like this, you should end up with 4 complex solutions, which I have right here, also counting repeats, but there are no repeats here. Right? Okay, so that's the long way of checking. Check by hand, but you should be checking your solutions. Now another way to check, and I like doing this on occasion when I'm strapped for time, but I still want to check my solutions, of course, is I have a TI-84 emulator on my computer. So if you have a TI-83 or 84, these are very similar. And if you notice right now, I'm in real mode up top. If you want to work with I, if you want to work with the imaginary number I have to change the mode. So I got to change this from real mode to, just complex mode, the A plus BI mode there. So that way I can actually use the imaginary number I. And let me show you what I'm going to do here. Let me take this solution here, and see, and let's check it. So that was the square root of 3, then divided by 3, and then times I, which is above the decimal point. I'll enter that number that I'm checking, and then I'm going to store it. I hit the store button, store it as x. Alright, so here we go. This is just whatever the square root of 1/3 is, rounded to 9, 10 decimal places here. Then times I, of course. Now every time I hit x, it represents that number. Alright. And then what I do is I go back to the original equation and enter the expression on the left, enter the expression on the right, if it has a variable. This one doesn't. So I'm just going to enter the expression on the left. We have 3 times x to the 4th power minus 2 times x squared minus 1, and see if I get 0. Remember here, x represents this square root of 3 divided by 3 times I, or the square root of 1/3 times I. And I hope I get 0, or something that would round to 0. Yeah, see, 0 plus 0i, this is 0. So that's excellent. This is a solution. And I leave it to you to do the same with the other 3. Right, with x equals negative square root of 3 divided by 3 times I, and then positive 1 and negative 1. I'll leave the rest of them to you, but as you saw me do by hand, all 3 of those also work in the equation. But this is just another way to check if you happen to have some sort of technology calculator that could do it also. Right, very nice. Okay. Yeah, so again, what I'm doing for all the rest of the examples in this video, is I'm going to first show you how the equation we're looking at is in this quadratic form. And then I'm going to make a replacement, right? Make a substitution to turn it into a quadratic equation with a new variable, right? And then we're going to solve this new quadratic equation for the new variable, then substitute back, solve for the original variable, and check those solutions back in the original equation, right? So that does sound like a lot, and it is. It can be, but if you do it enough, practice it enough, it won't seem so daunting after a while. So let's take a look at another one. All right, so example 2 is pretty similar to example 1. Another degree 4 polynomial equation, another quartic equation. But you notice, everything on one side, 0 on the other. You see how the exponent of the lead term is double the exponent of the middle term. And then I have a constant term, just like a quadratic would, And if you want to see how it's a quadratic, with squares and first powers, x to the fourth, again, that's x squared squared. Minus 8 times, and then, x squared you could think of as x squared to the first power. And then you have your constant term, minus 9, equals 0. And so this is definitely in quadratic form, where the u is x squared, right? The variable expression being squared in the first term and to the first power in the second term is x squared. So I'm going to make a substitution. I'm going to let x squared be replaced by u again. And again, you don't have to use the letter u. You can use whatever letter you want, right, as long as it's not x again. And now this equation becomes it turns into a quadratic equation in this new variable u, right? This first term becomes u squared minus 8 times u to the first, or just 8 times u. And then you have the constant term, minus 9 equals 0. And once again, you can use this. Let's solve this for u, this new quadratic equation. Quadratic formula, complete the square, but once again, being very nice to us here. This is a nice factorable polynomial. This factors to u minus 9 times u plus 1 equals 0. And so I'm getting the following, right? Applying the zero product property to this, u is either equal to positive 9 or negative 1. Right? Negative 1. And then we sub back, right? We're not trying to solve for u, right? The original equation had x's. So I'm going to sub back. Remember, u replaced x squared. So u equals 9 becomes x squared equals 9. And u equals negative 1 becomes x squared equals negative 1. And then with these, again, I can very quickly apply the square root property, right, where you have an expression squared equal to a number. So from x squared equals 9, we're getting x equals, the square root of 9, which is 3, or the opposite of that, right, this negative square root of 9, which is negative 3. Or, and then from this equation, x squared equals negative 1, we're getting the possible solutions of x equals, the principal square root of negative 1, which is I. Right? Remember, square root of negative 1 will be imaginary, that I number. Or x equals, the opposite of that, negative I. Right? If you square this, it'll still be positive I squared, which would be negative 1. And then, as always, don't forget to check these solutions. Now, these ones I'm just going to do mentally, like say them out loud. When you plug in 3, 3 to the fourth is 81. 3 squared is 9. 9 times 8 is 72. 81 minus 72 is 9. 9 minus 9 is 0, right? So 3 works. Sorry that was quick, but the same thing would go with negative 3, right? Because negative 3 to the fourth is still positive 81, and negative 3 squared is still 9, and you'd get all the same stuff that you got when you plugged in positive 3. Right, so negative 3 works, and I should work, right? Remember, I to the fourth is 1. I squared is negative 1, which would make this second term positive 8. You'd have 1 plus 8, which is 9, minus 9 is 0. And the same stuff would go for negative I, right? Negative I to the fourth would just be I to the fourth, right? Negative I times negative I times negative I times negative I would be positive I to the fourth, which would be 1. And then negative I squared would be just I squared, which would be negative 1. You get the same thing. You get 1 plus 8 minus 9 equals 0, which is true. Sorry I spoke very quickly there, but just want to get through the checking pretty quickly. And again, you can use a calculator if you wish, but all four of these are solutions to our original equation. Excellent. Now, if they asked you for just the real solutions, you'd say 3 and negative 3, right? The ones without I, but I don't think they asked us about that here. They just said find all the solutions, so all complex solutions. Why not? Great. All right, now this next example, you got x plus 2 squared plus 11 times the quantity x plus 2 to the first, and then a constant term minus 12. So it's got the setup of a quadratic right now. You got some variable expression squared, and then the exponent on the lead term is double the exponent of the middle term. And it's that same variable expression to the first power, right? X plus 2, x plus 2. So, and then you got a constant term, right? So this is definitely quadratic in form. So I'm going to make a substitution, just like in the previous two examples, right? It's obvious what to substitute for here. I'm going to replace these x plus 2's with u. Again, it doesn't have to be u. Be whatever other letter you wish. And that turns this equation into a new quadratic equation with this new variable u. So the first term is u squared plus 11 times and then u to the first, or just u, and then minus 12 equals 0. And then we solve this for u. Quadratic formula, complete the square, but once again this is nice and factorable. This factors to u plus 12 times u minus 1. So my possible solutions for this, for u here are u equals negative 12 or u equals positive 1. But I don't want to solve for this new variable. I mean I do, but I want to find the values of the original variable, which was x. So now we sub back. What did u represent? U represents x plus 2. So this first equation becomes x plus 2 equals negative 12. And this second equation becomes x plus 2 equals 1. And now there's no square roots involved here, right? We just have x to the first power in both of these. These are both simple linear equations. All I need to do is subtract 2 from both sides. So here we're getting x equals negative 14. And over here we're getting x equals negative 1. All right, and don't forget to check these, of course. All right, now when x equals negative 14, negative 14 plus 2 is negative 12. Squared would be positive 144. And then negative 14 plus 2 is negative 12 again, times 11 would be negative 132 minus 12 would be negative 144. You have positive 144 minus 144. That's definitely equal to 0. So negative 14 works. And then when you plug in negative 1, you just get 1 plus 11 minus 12, which is 12 minus 12. 12 minus 12 is equal to 0 for certain. So both of these for certain work in the original equation. All right, wonderful. All right, I got just one more page with something very similar to example 3 here, both these last couple examples. So example 4, clearly, again, it's already set up all the, not all of them, the last one's not, but this one's set up where everything's on one side, 0 on the other, and the way it's set up, it's clear that the first term has an exponent that's double the second term, And then you have a constant term, right? Just like a quadratic. This is definitely quadratic in form. The variable expression, to the second power and first power is the same. They're both x minus 5. So I'm going to do that substitution. Right? I'm going to replace x minus 5 with, u, like I've been doing. So now the equation becomes, a quadratic equation in this new variable u. It's u squared minus 4 times u minus 21 equals 0. Right, and then I'll solve this new equation for the new variable and then sub back and solve for the original variable, right? Just like I've been doing with all the other examples. Alright, so once again, we're given a very nice problem here where this is factorable, right? This would factor to u minus 7 times u plus 3. And so the solutions to this equation in u are, u equals positive 7 or negative 3. Right? But then we sub back. Right? We have to sub back. I want to solve for x, not u. Right? And what did u represent? Here it was this x minus 5. So we have x minus 5 equals 7 from this first equation. And then x minus 5 equals negative 3 from this second equation. And adding 5 here, we get x equals 12. Adding 5 here, we get x equals 2. Right? And then check them, of course. Alright, so if I use 12 for x, right, this will be 49 minus 28 minus 21. That's 49 minus 49 equals 0. That works. And if I plug in 2, we'll get 9 plus 12, which is 21 minus 21. 21 minus 21 equals 0. That's true as well. Right, so both those work. 12 and 2. Excellent. Alright, I got just one more like this. Alright, now it's not in the form that I want, right, where everything's on one side, zeros on the other, but hopefully you can see that this is like a quadratic, this will be quadratic in form. I got a term with t minus 1 squared, and then the next term has t minus 1 to the first. And then you have some constant term. Now I'm going to add that, right, so we have 4 times the quantity t minus 1 squared minus 9 times the quantity t minus 1 to the first, and then plus 2, equals 0. And again, hopefully it's clear that this is definitely quadratic in form. And I can make a quick substitution. Right, so here's the sub. Just replace these t minus 1s. Right? I'm going to replace t minus 1 with, u again. Why not? All right, why not? And, this turns this equation into a quadratic equation in u. Be 4 times u squared minus 9 times u to the first, or 9 times u. Then plus 2, equals 0. And again, you can use, the quadratic formula, completing the square method. But once again, we are given a polynomial here that can be factored pretty easily. Now you can factor it with the AC method or grouping, whatever you want to call that, or guessing and checking, but I can see how it's going to factor here. It'll factor to 4u minus 1 times u minus 2, and I leave it to you to check that, make sure that's correct. And our possible solutions here are u equals positive 1/4 or u equals positive 2. But again, I don't want these solutions. These solve this equation with the u in it. I want to solve for t. Right? The original equation had a variable t. So now that I've solved for u, right, I need to sub back. Instead of u equals 1/4, u was, t minus 1. So t minus 1 equals 1/4. And the other equation, u equals 2, becomes t minus 1 equals 2. And then I would add 1 to both sides. Here, t equals, I remember when you add, you need a common denominator, 1/4 plus 4/4. That's 5/4. And here you add 1, you get t equals 3. And then check these. Check them. Now, when t is 5/4, this would be 5/4 minus 1, that's 1/4. Squared is 1/16 times 4 is 1/4. Minus 9/4. 1/4 minus 9/4 is negative 8/4, which is negative 2. You get negative 2 equals negative 2. Excellent. And again, you can use a calculator if you want. I don't really care, as long as you're checking it properly. And then when t is 3, you're getting 4 times 4, you're getting 16 here, minus 18, 9 times 2, right? 16 minus 18 is negative 2. You get negative 2 equals negative 2 again. Hooray, right? So no extraneous solutions again. Right? Both work. 5/4 for t and positive 3 for t. Wonderful. All right, and that's all I got here. Notice that I did the same thing in every equation of this type. Got everything on one side, 0 on the other, and then hopefully you recognize that the equation you're looking at is in quadratic form. Now obviously if it's not in quadratic form, we're not going to try solving it this way. Right? But every single one of these examples ended up being in that quadratic form, and once you recognize that it's in quadratic form, it should be obvious what to substitute for. Right, then you make that substitution, turn it into a quadratic equation with the new variable, solve for that new variable, and then go back, substitute back and solve for the original variable, and check your solutions always, back in the original equation. Wonderful. Alright, I'm hoping that watching me go through these 5 examples here helps you in some way, when you're asked to solve an equation that's in quadratic form on your own. And thank you very much for watching.